You know that feeling when you pull off a wool sweater on a really dry day? You hear that crackling sound? Or maybe you've rubbed a balloon on your head and watched it stick to a wall. Well, that's static electricity. It's this invisible force that's pretty much all around us, all thanks to a little thing called electric charge. But how do you actually prove something you can't even see is really there? That's the question we're going to dig into today.
Right? It's a huge puzzle for scientists. If you can't see it, touch it, or hear it, how in the world do you show that it's real? This exact question, it's been the starting point for some of the biggest breakthroughs in history.
And the answer, it turns out, is this beautifully simple device, a gold leaf electroscope. And get this, the one we're looking at is based on a project from a group of 10th grade physics students. It's just a perfect reminder that sometimes the most profound secrets of the universe can be unlocked with just a few basic materials.
So let's get into how this thing actually helps us see the unseen. This isn't just some cool classroom project. It's a real deal scientific instrument. Its entire job is to detect that invisible world of electric charge and give us a signal, something we can actually see with our own eyes. Okay, so how does this simple jar pull off such a neat trick? Well, to get how it works, we first have to, look under the hood. So let's break down the anatomy of this awesome little charge detector. Everything starts right up here, at the top. You see this little brass disc? Think of it as the front door. When a charged object, like that balloon we were talking about, gets near it, this disc is what collects that invisible charge and invites it inside. So once the charge is on the disc, it needs a way to get down to the business end of the device. And that's where this brass rod comes in. It's a conductor, which basically means it's a super highway for electricity, giving that charge a clear, easy path to travel all the way down. And this is where the magic really happens. Down at the bottom of the rod, you've got these two super thin, incredibly delicate little strips of gold leaf. These are the stars of the show. They are the indicators, the part of the whole setup that's actually going to show us that the invisible force is there. And finally, the whole thing is sitting inside a glass bottle. Now, that's not just for looks. It has a really important job. It acts like a shield, protecting those super light gold leaves from any little puffs of air or breezes. This way, we know that if they move, it's because of electricity and nothing else. So we've seen all the parts, but how do they all work together? Well, it all boils down to one of the most fundamental rules in all of physics. Like charges repel. The specific scientific principle at play here is called electrostatic induction. I know, it sounds a little complicated, but the idea is actually super simple. It's just the ability to give something an electric charge without actually touching it. It's kind of like how a magnet can make a paper clip move without touching it. Same sort of idea. Okay, so let's walk through it. Imagine you bring something with a negative charge up to that disc on top. That negative charge flows down the rod and spreads out evenly across both of the little gold leaves. So now you have two leaves side by side that are both negatively charged. And what do like charges do? They repel. They push away from each other, and you physically see the leaves spread apart. And just like that, the invisible becomes visible. And here's what's really cool. It's not just a simple on or off. The amount the leaves separate tells you something. A really small charge might just make them flutter a little bit. But a big, strong charge, whoa, they'll fly apart as far as they can go. So it's a simple, visual way to get a sense of just how strong that invisible force is. So it's a pretty clever detector, right? But is it just a cool science demo, or what is it actually used for? Now that we know how it works, let's look at what it can do. So the student's report points out three main jobs for the electroscope. The first, and most obvious, is just detecting if there's any charge there at all. Yes or no. But you can also use it to figure out if the charge is positive or negative. And finally, like we just saw, you can use it to get a rough idea of the charge's strength or magnitude by seeing how far apart those leaves go. Now, you might be thinking, okay, this seems kind of old-fashioned. And you're not wrong. But its simplicity is exactly what makes the electroscope so important, even today. I mean, if you're just starting to learn about electrostatics, this device is a fantastic starting point. Historically, it was a game changer for early scientists trying to figure out electricity. And even now, there's probably no better tool for a teacher to physically show students how this stuff works. But the big idea here, controlling an electric charge, is the foundation of all modern electronics. The tiny transistor in your phone or computer, it's basically just a super sophisticated switch that works by controlling this very same invisible force.
You know, the students who built this thing really nailed it in their conclusion. They said, the electroscope is a simple yet effective instrument. And that's it, right there. It's proof that sometimes the most elegant designs in science are the ones that use just a few simple parts to reveal something massive about how the world works. It really makes you wonder, doesn't it? This simple little jar gave us a window into the invisible world of electricity. So it begs the question, what other invisible forces are out there, all around us right now, just waiting for the next simple, elegant invention to finally make them visible?